A rare visitor from deep space is racing through our solar system at unprecedented speed, and NASA's latest data has left scientists questioning everything they thought they knew about cosmic visitors. 3I Atlas, the third confirmed interstellar object ever detected, exhibits characteristics so unusual that some researchers are considering the unthinkable. Could this ancient wanderer be more than just a natural comet? As we uncover its secrets, the implications for humanity's understanding of our place in the universe become increasingly profound and, honestly, pretty terrifying. The breaking discovery. On July 1, 2025, the NASA-funded Atlas Asteroid Terrestrial Impact Last Alert System Survey Telescope in Rio Hurtado, Chile, first detected an unusual object later confirmed as 3I Atlas. This interstellar comet was initially spotted at a distance of over 4.5 astronomical units from the Sun, activating alarms across the global astronomical community. Its detection marked the third confirmed interstellar object ever observed passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. The initial observations revealed a hyperbolic trajectory with an incredibly high orbital eccentricity of 6.141, the highest ever recorded for any known interstellar visitor. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object, but a rare visitor that had been journeying through space for billions of years. The object's incoming velocity of 58 kilometers per second relative to the Sun marked it as the fastest interstellar object ever detected, surpassing both Oumuamua and Borisov by significant margins. From the outset, astronomers recognized that 3I Atlas was fundamentally different, initiating a worldwide mobilization of observatories dedicated to tracking this cosmic traveler and unraveling its profound mysteries. The discovery story. Between June 25 and June 29, 2025, the Atlas system had been gathering precursor observations that would later prove crucial in understanding 3I Atlas's trajectory and properties. These pre-discovery images, retrieved from survey archives and including work by the Zwicky Transient Facility at Palomar Observatory in California, helped confirm the object's interstellar path. Sam Dean, an amateur astronomer, contributed critical early tracking data, noting that the comet's trajectory through dense star fields near Sagittarius made early detection extremely difficult. The object's path passed through crowded cosmic neighborhoods, where countless background stars created a celestial camouflage, explaining why it had escaped discovery earlier despite being in the inner solar system for weeks. John Tonry, principal investigator of the Atlas project, immediately coordinated with facilities across the globe to confirm the object's characteristics once it was detected. The challenge of identifying 3I Atlas stemmed from its approach through regions where most sky surveys don't venture due to the overwhelming stellar background. This cosmic game of hide-and-seek had been ongoing since June 14, 2025, when the earliest pre-discovery images show the object silently crossing space. The rapid coordination between professional and amateur astronomers from multiple continents underscores the unprecedented global effort invested in monitoring this mysterious visitor. A stranger in our midst. 3I Atlas exhibits characteristics so unusual they continue to baffle the scientific community and challenge our understanding of natural cosmic objects. Traveling at a staggering 61 kilometers per second relative to the Sun, it far exceeds the speeds of its predecessors like Oumuamua and Borisov, making it the fastest interstellar visitor ever recorded. Its brightness is particularly notable, with a distinct coma and tail forming as solar radiation heats its surface, causing ice sublimation that creates spectacular visual displays. David Jewett from the University of California, Los Angeles, noted that the comet's tail and dust emissions provide rare data about materials formed in distant star systems billions of years ago. Perhaps most puzzling is that its trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun, an alignment with merely a 0.2% probability of occurring by random chance. This mathematical precision has prompted serious speculation about whether the object's path represents natural celestial mechanics or something far more intentional. The combination of unprecedented speed, unusual brightness, and statistically improbable orbital characteristics raises fundamental questions about whether 3I Atlas is truly a natural object, or represents something far more enigmatic that challenges our basic assumptions about interstellar visitors. the predecessors. So, to really understand the true significance of 3I Atlas, we have to take a look back at the two remarkable interstellar visitors that came before it, each bringing their own, well, unsolved mysteries. The first, 1I Oumuamua, was discovered in October 2017 by astronomer Robert Warwick at the University of Hawaii. It immediately stunned the scientific community with its elongated cigar-like shape and honestly, its completely unexplained acceleration away from the sun, all without any visible signs of outgassing. This mysterious acceleration just defied conventional physics and sparked some pretty intense debate about whether the object could be natural or possibly artificial. Then, in August 2019, amateur astronomer Gennady Borisov discovered 2I Borisov from his observatory in Crimea. This one proved to be a more traditional active comet, showing the typical outgassing behavior you'd expect from solar system visitors. The stark differences between these two ancient travelers, one mysterious and possibly artificial, the other conventionally comet-like, have really intrigued astronomers worldwide and, more importantly, set important baselines for comparison. Mark Norris from the University of Central Lancashire has pointed out that 3I Atlas, being the largest and brightest interstellar object yet discovered, gives us unprecedented opportunities to compare and contrast with its predecessors. This growing catalog of interstellar visitors is finally starting to reveal patterns that could unlock secrets about the diversity, origin, and true nature of these cosmic wanderers from distant star systems. The cosmic journey. 3. I-Atlas's trajectory through our solar system, honestly, follows a carefully orchestrated path that gives us optimal opportunities for comprehensive planetary observation. The object will reach perihelion on October 29, 2025, getting close to the Sun at about 1.36 astronomical units, positioned just perfectly between the orbits of Earth and Mars for extended observation. At perihelion, it'll hit maximum speeds of nearly 68 kilometers per second, which really shows off the extreme velocities you get with interstellar travelers. Paul Chodas from NASA's Center for Near-Earth Object Studies has calculated that while the comet poses no threat to Earth, keeping a safe distance of at least 1.8 astronomical units, its path brings it remarkably close to Mars, Venus and Jupiter during its trip through the solar system. The precision of this trajectory is pretty striking. It allows close approaches to 3 major planets and provides optimal vantage points for studying inner solar system dynamics. Karen Meach from the University of Hawaii emphasizes that this close approach sequence is, honestly, an unprecedented opportunity to see how an interstellar object interacts with different solar environments and planetary gravitational fields. The object will pass just 0.19 astronomical units from Mars on October 3rd, followed by a 0.65 AU approach to Venus on November 3rd, creating a sort of reconnaissance pattern that seems almost deliberately designed for a comprehensive solar system survey, rather than just a random cosmic passage. A scientific goldmine. 3I Atlas, really represents an unprecedented scientific treasure trove for astronomers and planetary scientists who are studying materials from beyond our solar system. With an estimated diameter somewhere between 0.32 and 5.6 kilometers, it's significantly larger than previous interstellar visitors. That means it actually allows for detailed study of its composition, structure, and evolutionary changes as it interacts with solar radiation. The Hubble Space Telescope, operated by teams led by David Jewett at UCLA, has been tracking dust emissions and nuclear activity, revealing ongoing sublimation of ancient ices and continuous dust release from the object's surface. These observations are providing crucial insights into the comet's volatile content and primordial materials, likely preserved for over 7 billion years, predating our entire solar system's formation. Stephanie Malam from NASA Goddard Space Flight Center is coordinating advanced spectroscopic observations using the James Webb Space Telescope to, hopefully, identify complex organic molecules and unusual isotopic signatures that could reveal the object's stellar birthplace. Current analysis has already confirmed the presence of water ice, both as solid grains and vapor, along with hydroxide ions, suggesting a water-rich composition that's typical of objects formed in the outer regions of planetary systems. The ongoing research aims to characterize the complete molecular makeup, including potential carbon monoxide, methane, and complex organic compounds, offering rare glimpses into the chemical building blocks and formation processes of distant star systems. Unanswered questions. Despite intensive global observation campaigns, 3I/Atlas continues to harbor profound mysteries that challenge our fundamental understanding of interstellar objects and their origins. The object's precise nuclear size remains frustratingly uncertain because the surrounding active coma obscures direct measurements of the solid nucleus, which complicates crucial density and mass calculations needed to determine its true composition and internal structure. While spectroscopic analysis has confirmed the presence of water ice and organic compounds, the detection of other expected volatiles like carbon dioxide and carbon monoxide remains elusive, raising questions about the object's formation environment and preservation mechanisms during its multi-billion-year journey through space. Julia de Leon from Spain's Instituto de Astrofísica de Canarias emphasizes that the object's unusual thermal properties and outgassing patterns don't conform to standard cometary models, suggesting either exotic compositions or structural characteristics not found in typical solar system objects. Perhaps most puzzling is the object's remarkable preservation state. How materials billions of years older than our solar system could remain so well preserved and chemically active after eons of exposure to cosmic radiation and interstellar conditions. Some researchers are beginning to debate whether the object represents a completely natural phenomenon or exhibits features that might indicate artificial construction or enhancement, a possibility that would fundamentally challenge our understanding of what's possible in the cosmos. The alien question. The possibility that 3I Atlas represents humanity's first encounter with extraterrestrial technology has, sparked some pretty intense scientific debate and forced researchers to confront some uncomfortable questions about the object's true nature. Avi Loeb, who's Harvard's Frank B. Baird Jr. Professor of Science, has really emerged as the most prominent advocate for seriously investigating artificial origins. He cites the object's statistically improbable trajectory, its unprecedented velocity, and honestly, its unusual structural characteristics as evidence that, warrant extraordinary investigation. Loeb's analysis suggests that the mathematical precision required for 3I Atlas's path, which actually provides optimal reconnaissance opportunities while passing close to multiple planets, exceeds what we'd reasonably expect from random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide, specifically searching for signs of artificial construction or technological signatures. However, mainstream astronomers like Sarah Seeger from MIT and Alan Fitzsimmons from Queen's University Belfast urge extreme caution, emphasizing that extraordinary claims require extraordinary evidence and that natural explanations should be exhausted before considering artificial hypotheses. The scientific community now finds itself balancing healthy skepticism with the recognition that, if 3I Atlas does represent extraterrestrial technology, the implications for humanity's understanding of our place in the universe would be, revolutionary, and potentially terrifying in their scope and consequences. Observing the visitor. Astronomers across the globe have mobilized an unprecedented array of telescopes and instruments to study 3I Atlas as it journeys through our solar system, creating the most comprehensive interstellar object observation campaign in history. Major facilities including the Very Large Telescope in Chile, NASA's Hubble Space Telescope, and the revolutionary James Webb Space Telescope are collaborating to collect multi-wavelength data that could, hopefully, unlock the secrets of this cosmic visitor. Michelle Bannister from the University of Canterbury notes that this coordinated effort involves over 50 professional observatories and, honestly, numerous amateur astronomers contributing observations and analysis. The Southern Astrophysical Research Telescope has been conducting detailed spectroscopic analysis to identify specific molecules and compounds in the object's coma and tail. Ground-based facilities like the Gemini Observatory and Keck Observatory in Hawaii are providing continuous monitoring of brightness changes, rotational periods, and thermal emissions that reveal internal heat distribution patterns. Canada, France, Hawaii telescope observations have captured deep images showing faint cometary activity even at great distances from the Sun. This international collaboration represents a new model for rapid response astronomy, with data-sharing protocols that allow real-time analysis and immediate follow-up observations when unusual phenomena are detected, ensuring that no critical information about this rare interstellar visitor is lost. Dawn of a new era. The detection and intensive study of 3I Atlas heralds the dawn of a revolutionary new era in astronomy, where interstellar objects transform from rare curiosities into, critical scientific targets that could reshape our understanding of galactic evolution and cosmic chemistry. Robert Jedica from the University of Hawaii estimates that technological advances, particularly the upcoming full operation of the Vera Rubin Observatory with its revolutionary LSST camera, promise to dramatically increase detection rates, potentially allowing astronomers to study dozens of interstellar visitors annually within the next decade. This technological revolution will create an unprecedented catalog of interstellar objects, providing statistical samples large enough to offer meaningful insights into galactic dynamics, planetary system formation processes, and the distribution of complex organic molecules across different stellar environments throughout our galaxy. Mark Norris from the University of Central Lancashire predicts that this growing database will reveal patterns in interstellar object populations that could answer fundamental questions about stellar evolution, planetary ejection mechanisms, and the chemical evolution of the Milky Way. As astronomers continue to unravel the mysteries of 3I Atlas and prepare for an influx of future interstellar discoveries, humanity stands at the threshold of a new cosmic perspective, one that will fundamentally transform our understanding of our place in the universe and the evolutionary history of our galactic neighborhood, potentially revealing whether we truly are alone or part of a larger community of cosmic civilizations. As 3I Atlas continues its mysterious journey through our solar system, it carries with it questions that could fundamentally alter humanity's understanding of our cosmic neighborhood. Whether this ancient wanderer represents exotic natural phenomena or, something far more extraordinary, the implications are honestly staggering. The coming months will be crucial as this interstellar visitor approaches its closest encounter with our sun, potentially revealing secrets that have traveled billions of years to reach us. Keep following InnoVision Tech for the latest updates on this developing cosmic mystery. Like, share, and subscribe.
A comet just erupted near the sun, and now a massive solar storm is racing to meet it on a collision course. In the next few weeks, Comet C/2025 R2 Swan will make its closest approach to Earth in recorded history, just as the sun unleashes its mightiest flare in months. This cosmic alignment is incredibly rare. We have a volatile comet, a powerful solar eruption, and a front-row seat from Earth. What happens when a solar storm meets a cosmic visitor? Let's explore this extraordinary scenario together.
First light. The outburst begins.
Comets are notoriously unpredictable, but what happened on September 26 caught everyone by surprise. Just 2 weeks after its closest pass to the Sun at a perihelion of 0.5 astronomical units, Comet Swan suddenly roared to life. Initially, it was a faint object, but amateur astronomers in Japan and Australia noticed a dramatic surge in brightness overnight. This wasn't a minor flicker. The comet's brightness leaped by a full magnitude, from 7.4 to a peak of 5.7, pushing it into naked-eye visibility under dark skies. What caused this? As the comet swung away from the Sun, intense solar heat penetrated its frozen nucleus. Pockets of sublimating cryovolatiles like frozen carbon monoxide and carbon dioxide buried for millennia reached their breaking point and exploded through the crust. This outburst ejected a massive cloud of gas and dust, dramatically expanding the comet's atmosphere, or coma, and feeding its enormous tail. According to cometary scientist Dr. Casey Liss of the Johns Hopkins Applied Physics Laboratory, such outbursts provide a rare glimpse into the primordial material from which our solar system was formed. This event signaled that Swan's inner engine was now exposed, making its next moves completely unpredictable, and turning it into a prime target for skywatchers worldwide. The sudden release of energy was so significant it altered the comet's light curve, deviating sharply from all predictive models.
Anatomy of a tail.
This isn't just a faint smudge in the sky. We're talking about a structure wider than 5 full moons laid end to end, stretching over 15 million kilometers through space, and its design tells a story. Comets actually have 2 distinct tails, and Swan's outburst put both on magnificent display. The first is the dust tail. It's broad, curved, and shines a pale yellow as it reflects sunlight. It's made of heavier micron-sized particles that are pushed gently by solar radiation pressure and tend to lag behind in the comet's orbit. The second, and more dramatic, is the ion tail. This tail is a narrow, straight ribbon of electric blue, composed of ionized gas like carbon monoxide ions, or CO+, which fluoresce brightly when excited by solar ultraviolet radiation. This glowing stream is blown directly away from the sun by the solar wind at speeds exceeding 400 kilometers per second, acting like a cosmic windsock. As noted by comet expert Carl Battams of the U.S. Naval Research Laboratory, the ion tail is a perfect natural probe of interplanetary conditions. With Swan's tail now stretching across a huge patch of sky, it has become a perfect natural laboratory, exquisitely sensitive to the solar storm that is now heading its way.
The sun awakens.
Just as the comet was putting on its show, the sun, which had been quiet for weeks, decided to join the party with its most powerful eruption in months. On September 28th, at 0843 Universal Time, satellites from the GEOES network detected a massive spike in X-ray emissions, jumping from a background level of 1 × 10 to the -6 to 6.4 × 10 to the -5 watts per square meter. An M6.4 class solar flare had erupted from a magnetically complex sunspot group designated Active Region 4232, then rotating into view on the sun's southeastern limb. M-class flares are the second strongest category, and a 6.4 is a significant event powerful enough to cause radio blackouts on the sunlit side of Earth. Scientists at NOAA's Space Weather Prediction Center, like lead forecaster Dr. Alexei Pevtsov, immediately began analyzing data from the Solar Dynamics Observatory's AIA instrument at multiple wavelengths, including 131 angstroms, to assess the flare's power and, more importantly, what it threw into space. The energy release was equivalent to millions of hydrogen bombs detonating simultaneously. The timing was incredible. Just 2 days after the comet's own eruption, the sun had fired a warning shot into the exact same quadrant of space.
Plasma on the move.
A flare is just the flash of light. The real power is in the billion-ton cloud of magnetized plasma it can hurl into space. And this one wasn't aimed at us. Within minutes of the flare, coronagraphs aboard the SOHO spacecraft, specifically the LASCO C2 and C3 instruments, confirmed that a massive coronal mass ejection, or CME, had been launched. This wasn't just a puff of smoke, it was a colossal bubble of solar material and magnetic fields, with an estimated mass of, well, about 1 trillion kilograms, racing outwards at a staggering speed between 800 and 1,000 kilometers per second. Forecasters at NOAA's Space Weather Prediction Center, using the WSA-Enlil prediction model, quickly charted its trajectory. The verdict: Earth was in the clear, but the CME was barreling directly towards the region of space now occupied by Comet Swan and its magnificent sprawling tail. Solar physicist Dr. Angelos Vorlidas, a leading expert in CME imaging, confirmed the CME's broad 90-degree angular width made an encounter highly probable. A rare and potentially violent collision was now inevitable within 48 to 72 hours.
Magnetic scissors.
So, what happens when a comet's tail, which is a magnetic structure, meets a massive magnetic cloud from the sun? Sometimes things just snap. This phenomenon is called magnetic reconnection, and it's one of the most explosive processes in the solar system. A comet's ion tail is made of plasma, held together by magnetic field lines streaming away from the sun. A CME, however, is a tangled web of powerful magnetic fields, often containing a strong southward-pointing component, known as the Bez field. If this southward Bez field, with a strength potentially exceeding 20 nanoteslas, slams into the comet's oppositely directed magnetic field, they can't merge. Instead, they collide, break apart, and explosively reconnect into a new shape. As space plasma physicist Dr. James Drake has explained, this process converts magnetic energy into kinetic energy with incredible efficiency. When this happens, the energy release can be immense, acting like a pair of magnetic scissors that cleanly severs the entire ion tail from the comet's head. This is called a disconnection event, and it can happen in a matter of minutes, leaving the old tail to drift away as a new one begins to form.
The forecaster's puzzle.
Predicting this collision is more complex than it sounds. It's like trying to predict if one puff of smoke will hit another in a hurricane. While models from NOAA's Space Weather Prediction Center, like the Enlil heliospheric model, showed the CME's main lobe sweeping through Swan's sector. CMEs expand, twist, and deform as they travel hundreds of millions of kilometers through space. Hitting a relatively small target like a comet's tail is not a guarantee. The biggest challenge for forecasters is the lack of direct measurements. Since the CME is not aimed at Earth, we won't get in-situ data from satellites like the DS-COVR spacecraft, which normally act as a warning system by sampling the solar wind a million miles upstream from us. Scientists must rely on images from spacecraft like SOHO and Stereo-A to refine the CME's trajectory and predict the exact time of impact. An error of just a few degrees in the initial launch angle can result in a 10 million kilometer miss by the time it reaches the comet. The best estimates place the arrival between 48 and 72 hours after the flare. But the question remains, will it be a direct hit, a glancing blow, or a near miss?
Citizen science mobilizes.
When a cosmic event like this unfolds, the big observatories aren't the only ones watching. A global network of backyard astronomers becomes the front line. Professional telescopes have schedules booked months in advance, so they can't always drop everything to watch a single event. But citizen scientists, however, can provide continuous round-the-clock coverage. This is crucial because a tail disconnection event can be incredibly fast, unfolding in less than 2 hours. An amateur astronomer with a modest setup, like a 10-inch reflector, and a modern CCD camera, could be the first person to capture the collision. Organizations like the Association of Lunar and Planetary Observers, ALPO, have entire sections dedicated to coordinating comet observations. Renowned astrophotographer Damian Peach has shown how high-resolution amateur images can rival those from professional instruments. These observers are not just taking pretty pictures, they are collecting valuable scientific data, or photometry, that can be used to measure brightness changes and map the tail's structure with incredible detail, helping to build a global record of this rare encounter.
The perfect alignment.
As if a volatile comet and a perfectly aimed solar storm weren't enough, the celestial geometry for this event is almost unbelievable. On October 21, 2025, Comet Swan will make its closest approach to Earth, passing just 0.25 astronomical units, or 39 million kilometers away. That's roughly 100 times the distance to the Moon. For a comet with an orbital eccentricity of 0.98 and a low inclination, that's an exceptionally close flyby. This proximity makes it an easier target for even small telescopes. The timing is equally perfect, coinciding with a new moon, meaning the sky will be at its darkest. But there's more. On that same date, a hypothetical interstellar visitor, 3I Atlas, reaches a superior conjunction on the other side of the Sun. As orbital dynamicist Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory would note, the probability of a dynamically new comet like Swan and an interstellar object aligning so closely in time and space is vanishingly small. This alignment provides a unique chance to compare a native solar system body with an interstellar one under the same solar conditions, a rare convergence of a dynamic comet, a potent solar storm, and an ideal observation window from Earth.
Southern skies spotlight.
For these crucial weeks, the best seats for this cosmic show are in the southern hemisphere. From major observatories like the Siding Spring Observatory in Australia to backyard setups in South Africa and South America, Comet Swan will be high in the sky after sunset. Its path takes it through the southern constellations of Grus and Piscis Austrinus, passing near the bright guide star Fomalhaut. Viewers can use this star as a guidepost to locate the comet, which will appear as a fuzzy star with a long, faint streak extending from it. Even a standard pair of 7x50 binoculars will be enough to reveal the tail, stretching over 2.5 degrees, the width of 5 full moons. For those in the northern hemisphere, the view will improve throughout October as the comet climbs higher in the western sky after midnight. The checklist for observers is simple: find a dark sky, use a star chart to locate the comet, and watch for any changes. By taking images every few minutes, observers can create time lapses that will reveal the tail's motion and any sudden disruptions caused by the solar wind in stunning detail.
Cosmic forces collide.
Here's the bottom line. We have a comet that has just undergone a massive outburst, making it unusually active and producing a large, dense tail. We have a powerful M6.4 flare that launched a CME racing directly towards it at nearly 1,000 kilometers per second. And we have a historically close and well-timed approach to Earth, giving us a perfect view. This sets up a documented encounter between a solar storm and a comet's ion tail, a phenomenon that could cause dramatic changes, with spectral analysis potentially showing Doppler shifts in ion velocities of up to 50 kilometers per second. It's important to be clear, as a scientist from a program like the NASA Comet Observation Database would emphasize, the comet's initial outburst and the solar flare are a coincidence. The sun did not cause the comet to erupt. However, this coincidence has created a rare opportunity for both professional and amateur observers to witness the powerful dynamics of our solar system in real time. The key results are still unfolding, written in gas and light across the night sky. A cosmic experiment for the entire world to watch. We are witnessing a truly unique cosmic alignment. A volatile comet, a powerful solar storm, and a front row seat from Earth. What will happen when the CME slams into Swan's tail is still unknown. Will it be a gentle ripple or a dramatic disconnection that severs the tail completely? The only way to find out is to look up. This is a rare opportunity for anyone with a pair of binoculars or a small telescope to contribute to a global science campaign. The universe is putting on a show, reminding us of the immense and unpredictable forces at play. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching InnoVision Tech.
What if the next interstellar visitor to our solar system isn't a tiny rock, but an object the size of a city, and it's heading our way? A chilling update on a mysterious object dubbed 3I Atlas has some of the world's top scientists whispering the word artificial. This isn't a comet. It has no tail, it's bigger than Mount Everest, and it's behaving unlike anything we've ever seen. Is this the event that changes human history forever? Let's explore this together.
Comet Atlas Mystery.
Before we get to the terrifying new object, let's talk about the original comet that put the name Atlas on everyone's lips. Here's why it matters. In late 2019, astronomers discovered Comet C 2019 Y4, also named Atlas. It was on a trajectory to become one of the most brilliant comets in decades, potentially reaching a peak magnitude of -5, brighter than the planet Venus. The hype was real, but as it neared its perihelion of just 0.25 astronomical units, about 23 million miles from the Sun in April 2020, it did something completely unexpected. It crumbled. Astronomer Quanji Ye of the University of Maryland, using the Hubble Space Telescope on April 20th and 23rd, watched as the comet disintegrated into a cloud of over 30 distinct icy fragments. Another study by astronomer Michio Kaku concluded the comet's nucleus was spinning so fast, likely with a rotation period under 24 hours, that centrifugal forces simply tore it apart before it could put on its show. This event was a stark lesson for astronomers. It showed that even seemingly powerful comets can be fragile and unpredictable. The mystery of the original Comet Atlas primed the scientific community for weirdness, but it was nothing compared to the new object that would share its name.
The Wow Signal.
What if this new object, 3I Atlas, isn't sending a message, but is the message? The transcript draws a spooky connection between this new visitor and the single greatest mystery in the search for extraterrestrial intelligence. On August 15, 1977, astronomer Jerry R. Amon was reviewing data from Ohio State University's Big Ear radio telescope when he found a signal so powerful, so clear, that he circled it and wrote, "Wow." The signal lasted for exactly 72 seconds, came from the constellation Sagittarius, and was broadcast at 1,420.4556 megahertz. That frequency is sacred in astronomy. It's the natural emission frequency of hydrogen gas, what physicists Philip Morrison and Giuseppe Cocconi called the universal calling card for any communicating civilization back in a seminal 1959 paper. The signal's intensity was over 30 times the background cosmic noise, a massive signal-to-noise ratio. And then, it vanished. In the 45 years since, despite over 100 dedicated searches of that same sky patch by scientists including SETI Institute senior astronomer Seth Shostak, it has never been heard again. It remains a profound cosmic question mark, A potential missed call that makes the arrival of a massive, silent physical object feel like the other shoe is about to drop.
Meet Avi Loeb.
When an object as strange and massive as 3I Atlas appears on the scene, you need a scientist who is not afraid to consider the impossible. Enter Avi Loeb, the former chair of Harvard University's astronomy department and the Frank B. Baird Jr. Professor of Science. Loeb is not a fringe theorist. He's one of the most prolific cosmologists of his generation, having authored or co-authored over 800 scientific papers. He became a household name for his bold stance on our first interstellar visitor, Oumuamua, arguing in his 2021 book Extraterrestrial that the most logical explanation for its bizarre behavior was that it was an alien artifact. He has consistently criticized the scientific mainstream for what he calls a failure of imagination. To back up his words, in July 2021 he co-founded the Galileo Project with entrepreneur Frank Lockien. This is a privately funded, systematic search for physical evidence of alien technology, aiming to get high-resolution data on objects like 3I Atlas. With a 7-mile-wide object now in the mix, Loeb's provocative questions have become more urgent than ever. He forces us to ask, are we so afraid of the answer that we refuse to even consider the possibility of an artificial origin?
Oumuamua discovered.
Before the alarm bells started ringing for 3I/Atlas, there was a dress rehearsal that broke all the rules. On October 19, 2017, Canadian astronomer Robert Warwick, using the Pan-STARRS 1 telescope in Hawaii, spotted a faint object moving so fast and on such a strange path that it had to have come from another star system. It was designated 1I/2017 U1 and given the name Oumuamua. It was our first confirmed interstellar visitor, traveling at a blistering 196,000 miles per hour, 87.3 kilometers per second at its peak. It was on a hyperbolic trajectory with an eccentricity of 1.2, meaning it was moving too fast to be captured by the sun's gravity. Its discovery was a stunning confirmation that objects from other stars wander through our neighborhood. It had already passed its perihelion on September 9, 2017, at a distance of 0.25 AU, and its closest approach to Earth on October 14 was about 0.16 AU, or 15 million miles. The discovery, as noted by NASA scientist Davide Farnocchia, officially opened a new window onto the formation of other solar systems, but it also opened a Pandora's box of questions that we are still struggling with today.
Strange behavior.
Here's where the mystery of interstellar objects truly begins, and it all started with Oumuamua. First, its light curve was bizarre. As it tumbled with a rotational period of about 7.3 hours, its brightness changed by a factor of 10. A team led by astronomer Karen Meach concluded this meant it had an extreme shape, at least 10 times longer than it was wide. But the real smoking gun was its movement. As it flew away from the sun, it accelerated. A team led by Marco Micheli of the European Space Agency confirmed this tiny but statistically undeniable non-gravitational acceleration of about 5 times 10 to the -6 meters per second squared. Comets do this when heated gas shoots from their surface. But the Spitzer Space Telescope, in an observation campaign led by astronomer David Trilling, stared at Oumuamua and saw absolutely nothing. No gas, no dust, no tail, placing an upper limit on dust production at less than a few milligrams per second. It was getting a push from an invisible force. This strange behavior is now being seen in a different way with 3I/Atlas. While Oumuamua was strange for moving without a visible tail, 3I/Atlas is strange for not having a tail when its immense size says it absolutely should.
Light sail theory.
If Oumuamua wasn't a comet or an asteroid, what was it? This is where Avi Loeb, along with his Harvard colleague Shmuel Bialy, proposed a radical theory in a 2018 paper in the astrophysical journal Letters. They argued that Oumuamua's mysterious acceleration could be perfectly explained by the pressure of sunlight itself. For this to work, the object had to be incredibly thin and lightweight, with a large surface area, essentially a sail built to be pushed by light. They calculated its thickness would need to be less than a millimeter, with a very low area-to-mass ratio. Its density would have to be around 0.1 grams per cubic centimeter, far less than that of a typical icy comet, 0.6 grams per cubic centimeter, or rocky asteroid, which is over 2 grams per cubic centimeter. This light sail is a technology that humans are actively developing for interstellar travel, most notably through the Breakthrough Starshot initiative, for which Loeb chairs the advisory board. The stunning implication of their theory is that a light sail cannot be natural, it must be engineered. It established a critical intellectual framework. When faced with an object that defies all natural explanations, an artificial origin must be considered a scientific possibility.
Universe age debate.
The arrival of something as seemingly impossible as 3I/Atlas is made more plausible by a simple fact: our entire understanding of the cosmos is currently being rewritten. For decades, the age of the universe was confidently stated as 13.8 billion years. But, the James Webb Space Telescope is now sending back data that challenges this fundamental number. Astronomers like Rohan Naidu of the Harvard-Smithsonian Center for Astrophysics have used the JWST to identify surprisingly mature and massive galaxies at a redshift of 13. This means we are seeing them as they were just 330 million years after the Big Bang, far too developed to fit our current models. This data, some from the Cosmic Evolution Early Release Science or SEERS survey, has led some physicists, like Rajendra Gupta of the University of Ottawa, to propose the radical idea that the universe could be as old as 26.7 billion years. This ongoing debate, fueled by JWST's principal investigator for extragalactic deep surveys, Stephen Finkelstein, reveals a crucial truth: our cosmic knowledge is still in its infancy. If our most basic timeline of the universe could be wrong, then our assumptions about what is possible within it are also on shaky ground.
NASA spy agency.
If a 7-mile-wide object of unknown origin were on a path through our solar system, who would be in charge of the response? While we think of NASA as an agency of peaceful exploration, a 2020 executive order quietly reclassified some of its functions to include intelligence, counterintelligence, investigative or national security work. And, while NASA Watch editor Keith Cowing noted this was largely a bureaucratic move related to federal labor laws, it highlights a deep, underlying reality. NASA has long collaborated with the Department of Defense and the National Reconnaissance Office, or NRO, which actually gifted NASA 2 Hubble-class spy telescopes, each with a 2.4-meter primary mirror, back in 2012. This collaboration, often managed by former NASA administrators like Charles Bolden, means that in a first contact scenario, NASA's assets, from its worldwide deep space network to its fleet of planetary probes, would instantly become the front line of global intelligence gathering. The line between pure science and national security would just evaporate. That quiet reclassification is a reminder the government's plan for contingencies we aren't told about, and when faced with a visitor like 3I/Atlas, NASA's mission could shift from exploration to defense overnight.
Interstellar visitors.
For centuries, we thought our solar system was an isolated island, but now we know it's more like a busy port of call. The discovery of Oumuamua in 2017 was the first confirmation. Then, just 2 years later in 2019, amateur astronomer Gennady Borisov discovered a second interstellar visitor, 2I Borisov. But Borisov was different. It looked and acted exactly like a normal comet, with a visible gas and dust tail and a nucleus estimated to be about 1 kilometer in diameter. This discovery was crucial. It showed that other star systems produce normal comets just like ours, which only made Oumuamua's weirdness stand out even more. Now, with the potential discovery of 3I/Atlas, we're entering a new era. The Vera C. Rubin Observatory, once fully operational, is predicted by its director Jelko Ivasic to find dozens of these interstellar objects every year. Yale astronomer Gregory Laughlin has calculated that trillions of such objects are likely roaming our galaxy. Most will be rocks, but if even a tiny fraction of 1% are probes, our solar system could be getting visitors on a regular basis. We just never had the technology to see them until now.
Humanity and war.
The appearance of a colossal object like 3I/Atlas forces humanity to look in the mirror, and honestly, the reflection is not flattering. How would we react? This question brings us to the Fermi paradox and the chilling concept of the Great Filter. The paradox asks why, given the probability, we haven't found any other civilizations. One of the most terrifying answers is that civilizations destroy themselves before they achieve interstellar status. This self-destruction is known as the Great Filter, a term coined by economist Robin Hanson in 1996. Carl Sagan often discussed how a civilization's technological mastery of weapons could be the self-imposed limit. This is explicitly quantified in the Drake equation formulated by astronomer Frank Drake in 1961. One of its key variables is L, the lifetime of a communicative civilization with a current global arsenal of roughly 12,500 nuclear weapons. The value of L for humanity remains terrifyingly uncertain. The idea that a civilization can transcend its tribalism is the ultimate leap of faith. 3I Atlas isn't just a test of our science, it's a test of our maturity as a species. From a 7-mile-wide silent anomaly to the bizarre precedent set by Oumuamua, the evidence is mounting that we're entering a new era of astronomy, one where we must be prepared for anything. The object known as 3I Atlas represents the greatest question ever asked: are we alone? Whether it proves to be a natural wonder or something far stranger, its presence in our solar system is a humbling and, yeah, perhaps even a terrifying reminder of just how much we have left to learn about our place in the universe. The mystery is just beginning, and the next piece of data could change everything we know about our reality. What do you think 3I Atlas could be? Let us know your theories in the comments below. Don't forget to like, subscribe, and hit the bell icon for more explorations into the final frontier. Thanks for watching InnoVision Tech.